24. A. 3 carts of masses 4 kilograms, 10 kilograms, and 3 kilograms move on a frictionless horizontal track with speeds of 5 meters per second, 3 meters per second, and 4 meters per second, as shown in figure P924. Velcro couplers make the carts stick together after colliding. Find the final velocity of the train of 3 cars. B. What if? Does your answer require that all the carts collide and stick together at the same moment? What if they collide in a different order? And then they proceed to give you a diagram. So the first thing that I did was I redrew the diagram. Just pretend that these are all on a frictionless horizontal plane. And I'm just going to call this first mass, mass 1, this is mass 2, and this is mass 3. So first we're just finding the final velocity when all 3 of these are Velcro together and moving toward the right. We can tell that it's going to be moving toward the right just because the masses here are larger and at a combined greater speed than this one mass. So it's because just conservation of momentum, we probably know it's going to move to the right. But to check that, we have conservation of momentum, momentum initial equals momentum final. And our two cases are 2 scenarios. The initial scenario when they're all separate and they're all traveling at their given speeds. And then finally, when they're all together and they're traveling at their final velocity. So first m1 v1 plus m2 v2 plus m3 v3, which is all the combined initial velocities as them separate, equals, because it's an inelastic collision, they stick together at the end, it's m1 plus m2 plus m3 as a total mass times the velocity. So we just do m1 v1, m1 is 4 kilograms times v1 is 5 meters per second, m2, 10 kilograms, v2, 3 meters per second, and m3 is 3 kilograms, and then v3 is negative 4 meters per second, equals 4 kilograms plus 10 kilograms plus 3 kilograms, which is here, plus vf. So if you add everything up together, we can see that we get 38 kilogram meters per second equals 17 kilograms times vf. Then if you just divide, we see that vf equals 2.24 meters per second. So using conservation of momentum, we found that at the end, when they're all sticking together, they'll all go to the right at 2.24 meters per second as one huge block. But now they ask the question, does your answer require that all the carts collide and stick together at the same moment? So this is a conceptual problem. And because we use conservation of momentum, the answer is nope. It does not matter the order of the collisions because in the end, because it's frictionless, because it's purely horizontal, it doesn't matter the order. Or how we get there. We just know that momentum initial equals the momentum final. It doesn't matter how you get there. But let's just, for argument's sake, pretend that these two, the 4 kilogram block and the 10 kilogram block, going both to the right, they collide first. They stick together first, and then together they collide with a 3 kilogram block that's going negative 4 meters per second. If our hypothesis is true, then the final velocity after this collision first and then this collision should be 2.24 meters per second. If really it doesn't matter the order of the collisions. So we're first going in collision 1, which is here. Energy initial equals energy final. So you got m1 v1 plus m2 v2 equals the masses together times the velocity. That's the velocity in which they're going to be traveling when they hit m3. But first we see 4 kilograms times 5 meters per second, that's how fast it's going, plus 10 kilograms times 3 meters per second equals the combined mass, which is 14 kilograms times v. If we just solve that out, we get v equals 3.57 meters per second. That means that this is traveling at 3.57 meters per second when it hits this 3 kilogram block. So our second collision is just momentum initial equals momentum final. We got this big mass that's now Velcro together, so 14 kilograms, times our velocity, which was just found, is 3.57 meters per second, plus this and the initial velocity of this block, which is 3 kilograms, times negative 4 meters per second, because it's going in the opposite direction, equals the masses that are combined, because these are going to combine together, times your velocity. And hopefully this velocity turns out to 2.24 meters per second. And it does. If you just, combine these, and you divide 17 kilograms by this, you are going to get a final velocity of 2.24 meters per second, which matches our final velocity here. So in the end, because of conservation of momentum, the order of collisions doesn't matter. It has no effect on the final velocity.